Hello, this is my lab report for Lab 1 of Physics 2211. This lab focuses on constant velocity in one direction. We will be using the momentum principle and Newton's laws. The momentum principle states that the change in momentum is equal to the net force multiplied by the change in time. And Newton's second law states that F equals ma. Our model is an object moving in a straight line. We would assume that the direction of travel and momentum of this object does not change because there's no unbalanced force acting upon it. After conducting a physical experiment, we found that the results that we got did not line up with our predictions. This suggests that in the physical experiment, there was an unbalanced force acting upon our object. For the physical experiment, we found an object and pushed it in a straight line. We recorded its motion and then used Tracker to analyze the video and obtain data. The system for our experiment is the little box you can see on the left, and the surroundings include the track it is sliding on and also the air. We want to study constant velocity, so t equals 0 is when the object has reached a constant velocity a little bit after we gave it that first push. For the program, we set our initial conditions. T equals 0, position equals 0, and velocity in the x direction is 1.129 meters per second. Then we go to our while loop. Here we update our position and time, one frame at a time, and we also create our visualization and output our predicted data. When we compare our observed data to our simulated model, we see a significant difference. The final position of our observations was less than the final position of our simulation. There's also the difference in velocity. For our simulation, we assumed that velocity would be constant, but in our experiment, the velocity was not constant, it was decreasing. Using our physics principles, we know that momentum equals mass times velocity. The mass was constant in our experiment and velocity was decreasing. That means the momentum changed. When there is a change in momentum, we know that there must also be a force acting upon our system. There are some sources of error that may have affected our data. The first is the video itself because it was not completely perpendicular to the motion of the object. The second comes from human error when I was collecting data points using Tracker. When we analyzed the video in Tracker, we set our origin to correspond with our initial conditions. We also made it so that our object will be traveling in the positive x direction. If we chose to make our object travel in the negative x direction, the meaning of our results would not change. They would only multiply them by -1. So for example, the final position would end up near negative 1.5 meters, and the velocity would have a positive slope, and the initial velocity would be near -1 meters per second. While we did not calculate the net force in our experiment, it is possible to do so. Force equals mass times acceleration. The acceleration can be calculated using our position and time data. And then mass, we would have to measure the mass of the object we used. Overall, while our simulated model may be good at predicting motion in one direction when there is no net force, that may not always be true in the real world. In our physical experiment, we found that we had a non-constant velocity. It started off around 1 meter per second and slowly decreased to around 0.75 meters per second. Since the velocity changed, we can use the momentum principle and Newton's second law to say that we had a non-zero net force. We suspect that this non-zero net force is due to the surroundings affecting our system through the form of air resistance and friction.